Good evening, students. Ruchi sir again today with a new interesting question. Same capacitance topic. I'm going to discuss the pressure rise inside a liquid dielectric in the gap of the capacitor when the capacitor gets charged. These are my credentials. As you all know, by now you must be knowing me very well. Okay, we go to the question. A parallel capacitor is placed inside water. Water is taken as a dielectric with a K value almost 81. So that parallel capacitor is placed inside water in a horizontal position. Water fills the gap is D between the plates. A constant voltage V0 is applied to the capacitor. The constant voltage V0 is applied to the capacitor plates. Find the increment in pressure in the gap. K of water is 81. Okay. Solution. Let A be the plate area of the capacitor. X be the gap width. What is the capacitance in air or vacuum? Epsilon A by X. All of you know parallel capacitor. The capacitance when it is inside the water filling the gap. What do you see there? Just K of water multiplied to epsilon naught. So K epsilon naught A by X, that you must be knowing. K is the dielectric constant of water. Since the applied voltage is V0, when the water fills the gap, how much charge it is? C into V0. That's very important. That is a very common and important point to note. Charge capital Q is this. Now, I think in my previous class, I discussed what is the mathematical definition of force in electrostatic field. So if we discussed as minus dou U by dou X at that value of Q which is present right now, which is creating the field. So this minus dou U by dou X keeping Q constant. Okay. U is equal to Q square by 2C. So minus outside Q square by 2 outside d by dx of 1 by C. This is the force. Okay. Now find out what is the force on the capacitor plate which this charge Q present. How much water means when FW means the force on the capacitor plate when the dielectric is what? So that is minus Q square by 2 d by dx of 1 by C is 1 by K epsilon 0 A by X. X goes up. So this. So Q is already K epsilon 0 A by X V0. Square it by 2. Minus sign is there. D by dx of X by K epsilon A. So K epsilon A, take out 1 will get cancelled, 1 V0 square will remain, X square will remain, 2 will remain, and dx by dx is 1. And minus sign remains as it is. This is a minus sign. FW is minus, negative. What do you mean by negative? I discussed earlier, if you remember. Negative means FW. W means again what? This is force on the capacitor plate when the dielectric is water. So how much it is? Minus K epsilon 0 A V0 square by 2x square. So negative means the force direction is pointing towards the decreasing direction of X, means attractive force. Force tries to decrease that X value. If this is X, the force tries to decrease the X value. Okay. that means attractive force. I wrote it very clearly here, attractive force. Okay, this is the force right now when the capacitor is immersed inside the water, when the gap is filled with water dielectric. But suppose the same dielectric was not present, but charge was same, because I am keeping the charge same. With the same charge on the plates of capacitor, this charge remains this value only. This charge remains this, whatever is there right now in the water capacitor, same charge I maintain in the air capacitor or vacuum capacitor. So what will the force of the plates? Same, minus q square by 2 d by dx of 1 by c minus q square by 2 d by dx of x by epsilon of A, because in air capacitor the k is 1. So, but what is this? Remaining the same q. What q? This q which I have discussed for the water capacitor. So k epsilon 0 A V naught by x. The same q square by x square by 2 d by dx of x by 1 by epsilon 0 A. So k square epsilon 0 A V naught square by 2x square minus sign, again attractive force. So the same charge in the vacuum capacitor would have been a bigger force, because k square, and compare it with equation 2, it is k only. So k is greater than 1, so k square is greater than k. Just compare here. These two values. This is in FW, this is FA. A means air in the gap or vacuum in the gap. So which is bigger, beta, magnitude wise? Both are attractive, but which is bigger magnitude? Air one is bigger magnitude. So in air, the force of attraction between the plates would have been quite large, larger compared to when water is. Why so? Same charge is there. Why so? Because the inside the dielectric water must be pushing it outward, so that the net force becomes this. So that's what I found, that the k square epsilon 0 A V naught square by 2x square. This is the attraction force in the vacuum capacitor, which gets reduced when water is introduced, because the water as a dielectric will be trying to push it away. That means what is saying, FA greater than FW magnitude, and both are attractive. When I compare the magnitude, I'll write like this. Inside water, this not inside water, inside the capacitor, inside the gap, the water must be pushing out the capacitor plates, so that the force becomes smaller, less compared to air or vacuum capacitor. Understood this? So this pushing out force I want to calculate. Suppose this force is attractive force in air is 10 Newton. But once I put the water, it becomes 8 Newton. Obviously, water is pushing it out with a force of 10 minus 8, 2 Newton. That's what concept I'm using here. So F dash, the outward pushing force by the water and the capacitor plate, becomes Fa magnitude minus Fw magnitude, k square minus k. Other things are common. Epsilon naught A V naught square by 2x square. Just look at this. Epsilon naught A V naught square by 2x square. This common. For air it is k square, for water it is k. So this difference is the F dash. F dash is what? The force, outward pushing force by the water on the capacitor plate. So that's what. So F dash, we found that to be this. So he's asking this is the F dash pushing out. So plate also will push back the water with same force. So water, the pressure increases in the gap on the water. So by how much the pressure increases? If I don't have any charge, it will have normal pressure PA. But since after charging, the extra force F dash is coming onto this. So that F dash will create a pressure rise delta P. So delta P will be F dash by A, plate area. So epsilon naught K minus 1, V naught square by 2D square. This is the answer. Very simple question. I'm showing the diagram also. See the diagram. This is a small attraction force. This is an attraction force with air, Fa. Once I place it in water, this becomes Fw, a smaller one, means the water must be pushing it out with F dash, so that the force becomes smaller from Fa to Fw. So Fa minus F dash Fw magnitude. That's what I did not change the charge while applying this. So charge remaining same, Fw is less than Fa, so both are attracting. So F dash by the dielectric, or that is by water, is outward direction pushing out the plates. I just give numerical values. V naught is 500 volt, T is 1 millimeter, K is 81. Delta P is just putting the values. Epsilon naught K into K minus 1. Epsilon naught K is 81, K minus 1 is 80 into P naught square by 2D square, actually 2 into millimeter into minus 3 square into minus 6. So that gives us around 7.2 kilopascal, 7.21 something it may be. Okay, I think all of you clear here. Am I clear? So this is a very nice question. So that clarifies that F is equal to minus dou U by dou X, keeping that Q unchanged, irrespective of whether the capacitor is connected to battery or not connected to battery. As long as Q is one particular value, you can use that expression. F is equal to minus dou U by dou X at that value of Q. Okay, so this is a question I wanted to discuss to elaborate on the force expression which I gave previous class. So I think this one I used in previous class. So I think you are clear. If you are not clear, you can contact me. So I'll again discuss some important points in this capacitor, like losses and all this, that we'll discuss. So in between, some interesting questions also I'll discuss with you. Keep track of my channel. Whenever I give you any new topic I discuss, you will get information. Don't forget to subscribe and give your comments. What else you require, I'll try my best to discuss that. Thank you all. Have a nice day.